What's up, everybody? We are about a couple weeks away from the midterm, by the way. So here we are at week 5, the end of week 5. We're going to finish covering functions today, but then we're actually going to keep using functions. Pretty much after today, we're going to see this every day, right? Every single topic ahead of this is going to use functions. Okay, but yeah, I do want to give a heads up that midterm is in a few more weeks, week 8. We'll spend a solid week before it, just kind of, taking a review, taking some random questions, letting folks catch up. I'll also deliver a practice midterm so folks can get prepared on what's on the actual midterm. All right, let's finish up functions. A quick little thing before we jump into it. There is an assignment called Robot Cat. This is the second version of Robot Cat. So if folks want to take a crack at it, I'm not really going to open up this notebook. It's really just the same as the first project, right? But it's going to ask you to write functions, and your robot is going to look a lot cleaner. Pretty much, you'll be able to write 2 functions and then finally just draw certain shapes. Here's what I mean. So in the robot cat here, see, I don't even have it. I don't even have it downloaded. I should probably download it real quick. Okay, let me download it. Let's give a quick sneak peek on this, and then we'll finish up functions. Let's see. Okay, Robot Cat 2.0. This one is the most recent. So let me go ahead and download it. Download. Boom. Create a folder for this. Robot Cat. I'll call it 2.0. Okay, there it is. Cool. Let me run this first cell. So yeah, this is really just the same assignment as the very first week. If anything, you kind of want to go ahead and count the shapes, right? Like how many triangles are there? There's 1, 2, 3, 4, 5, 6, 7. Right, there's 7 triangles. How many squares are there? There's 3 squares. Right? These 2 eyes, and then the big box. Right? So there are 10 shapes in total, meaning that if you were to write 2 functions, right, one function called triangle, one called square, right, then that means you can pretty much draw this using like 10 function invocations with some moves in between, right? Because you do have to move the turtle a bit and then drop a square certain places. But yeah, the code should look a lot cleaner. Okay, so that's about it for that. Let me jump into the lesson. Cool. Okay, let me load it up. So we are gonna finish up functions right here, functions, and then the lab should go with it. Lab number 10. There we go. Okay, let's see where we left off. A couple of days ago, I think we finished most of this lessons notebook. Let me see. Okay, we got all the way down here, all the way down to power of. Okay, you know what? We actually finished most of this lesson. I think we left off on this lab. We left off, I asked folks to try to get the rest of this lab done. And yeah, so we left off number here. Number 3, returning from a function. The first 2 questions don't really have any return statements. So if you were here a couple days ago, all these first 2 did was print something. Right? Number 1 is, just print the argument. And then number 2 said, print the sum of the arguments. Right? These aren't actually returning anything, right? Meaning that if someone were to call the function, they wouldn't be able to capture any value. So finally, number 3. Number 3 is really the same thing as the previous one. Right? It's really asking us to calculate the sum, but also return it in the end. So it's going to be the same exact thing. If anything, this lab is more of an exercise on if folks can understand the directions. These directions, it might seem super easy, but it's kind of like organizing all of these, right? Like write a function called do sum return, right? This right away we should be able to define do sum return, right? And then a function does have these parentheses and then the arguments in here. In this case, the question is asking us for two arguments, a and b. So we can go ahead and put that here, a comma b. And then finally, return the sum of these two arguments. It's the same thing as above, but instead of printing it, we're going to return it. Okay, so let's do that then. So here it's going to, there's a couple ways you can do it. You can do it in one line, right? You can just return a plus b, right? Or you could store the result and then return it in the end. Right, so I'm going to do it like this, just to be more explicit. Calculate it, then return it. Okay, so that's what it's asking for. If anything, I'm going to go ahead and test it. Right, so I'll test it by invoking the function. Return AB. AB, they are floats, right? I know some folks might be testing by doing A and then B right here. I'll talk about pitfalls later. This is not valid. A and B doesn't even exist. So it's going to say A and B doesn't exist. But these are supposed to be actual values. I'll talk more on this later, but one way you can do it is just by putting in like 2 and then 5 here. All right, let's go ahead and run it. And it evaluates to 7. And I do want to reiterate that it is not printing. Right? It does look the same as above, but it's not printing. Meaning, if I were to call it again, all right, let me copy and paste this. So copy and paste this with like 3 and then 8, just some random numbers. It should print 11, right? Or not print, it should evaluate to 11. So I'll go ahead and press play. And yeah, see, it evaluates to 11, right? But that's, once again, this is because it's Jupyter Notebook showing the value of this last run statement. Right? And here, the value is 11. So this first function call, right, it is being calculated, but nothing is happening with it. It's calculating it, it's being returned, but then it's forgotten right after. So if you wanted to capture it, right, you could do something like result 1 is equal to that, and result 2 is equal to this, right? This way we're actually capturing the return value, and then if you want, you can go ahead and print it in the end. Result 1. All right, there we go. It prints both 7 and 11. Okay, let me go ahead and run this feedback. This feedback is probably gonna say I don't have a doc string. Let's see. Oh, I forgot to run the first cell. I restarted my server. So let me run this first cell. Boom, run the first cell. And then let's ask for feedback. Missing some return. Oh, I need to run this cell again. Attention needed. Okay, function should have a doc string. Cool, I just had to rerun some cells because I didn't run the first one earlier. Okay, function should have doc string. Let's put one in real quick. This function is really just a fancy version of the plus sign. All right, it seems overkill. Like, why are we typing so much just to represent the plus sign? Okay, it's just to practice following directions, like understanding how to break this down. Okay, so here purpose is, it's really just a wrapper for the plus operation. for the addition operator. Addition operator means plus sign. Okay, and then what else? There's some arguments here. All right, there's A. This is a number to add, and then B is also another number to add. All right. Cool. There is a return. All right. Once again, the docstring talks about its inputs and its outputs. So I'm going to talk about its return statement. It returns the sum of the two arguments. Okay, I hope you are cool with this. Cool, let's make sure the feedback is good. Okay, all tests passed. Looks good. All right. Now a couple more and we'll be done. Let's see, returning a Boolean value. Okay, write a function called isGreater that takes two arguments, A and B. Okay, so boom, and then this time is going to return a Boolean. Instead of some number, it's going to return either true or false. So anyways, here, from the first sentence, we should be able to right away define a function. Right? Define isGreater. Right, there we go. Just setting up the skeleton of it. Takes two arguments, A and B. So A comma B. And then here we go. Here's the hard part. The function returns true if A is greater than B and false otherwise. So this means that we need to compare the two arguments and return some result. This is kind of a review on a long time ago. I think week 1 or something. In week 1, we talked about the operators. You might remember that there's a greater than operation that returns a Boolean. Right, so this means that if you were to compare two numbers, the expression will evaluate to either true or false. So that's what we're going to take advantage of. Okay, let's see, is greater. Right, if anything, we need to calculate something. So you could say, oh, result, right? I could declare some Boolean variable and set it equal to the result. That the result is whether or not A is greater than B. And that's it, and we just got to return the result. So let's go ahead and test it. A is greater. I'll go ahead and call it is greater, and I'm going to put in two values here. Let's see, put in like 4 and then 5, or 4 and then 10. It doesn't matter. Okay, just sanity checking real quick. Is 4 greater than 10? No, it's not. So hopefully it evaluates to false. Perfect. Okay, let's test another one. Let's swap the order. Let's go 0, 10, and then 1. Right? Is 10 greater than 1? True. Okay, cool. We're just sanity checking. Great. So it looks like we're good. If anything, this is, once again, it's just a wrapper for the greater than operator. Right? I know it seems overkill, but we'll do more complex functions later. And so all we're doing is wrapping this. So it's just an exercise to follow directions. This way people can get used to all of this vocab, right? Getting used to, oh, what's an argument? Oh, what's a return value? Hopefully by now folks know what it is. Right? Arguments are inputs to a function, and then return values are outputs from that function. Okay, cool. Let me put this docstring in here real quick. So this is really just a wrapper for a greater than operator. Okay. Okay, cool, got that. And then there are two arguments in here, right, or two parameters. A is expected to be some number. I mean, in particular, it could be a float as well. It could be a decimal. A number to compare. B is also another number to compare. All right, cool. Let me test it. play, play, and play. And all tests pass, looking good. Okay, great. So we did all these functions in part one. Finally, there is part two. I'm gonna let folks try this out themselves. Part two is pretty short, and we actually already did this in the lesson. So if you want to take a look at the previous recording or the previous content, we already did part two in the lesson. All right, now number one is saying, hey, implement a function that draws a triangle of some size. Right, and then number two is asking if you could draw a triangle that looks like this. It's pretty much saying, can you invoke the function from above? So yeah, go ahead and give this a shot. If anything, maybe let's take like a 10-minute intermission to see if folks can do it. So yeah, once again, we already did this. I'm gonna scroll up a bit. Right here on Tuesday, see we wrote a function that draws an equilateral triangle. So you can pretty much do this again, and then you want to redo this. Draw a triforce. Right, if you can make it look exactly like this, not really talking about the size, I'm talking about the orientation. If you could get the orientation like this, that would be great. Because on Tuesday we attempted it, but the orientation wasn't really there. The orientation from last lecture was like this right here. Oh, whoops. Right. See, this was stuff from Tuesday. It didn't exactly look right. Okay, yeah, so go ahead and give this a shot. We'll give it like a 10-minute intermission, part two. Okay, cool. We're back from intermission. Hopefully folks give that a shot. Okay, we should be done with the lab now. Let's do a couple more things and wrap up functions. Or actually, we're not going to be finished with functions until the end of the semester, actually. Every single week, we'll be working with a function. Anyways, looking back at the lesson, I'm not going to cover everything here. There's going to be some optional things in here. But I did want to go over some possible pitfalls, and then right after that, go into a application. In particular, if folks are trying to maybe see how functions can be Legos and put the Legos together later, we'll do an example called Roulette. So stick around if folks are interested in implementing Roulette in Python. Okay, but first, I wanted to jump into a couple pitfalls on functions. So I'm actually going to do this in a brand new notebook, just so it's a little cleaner. Okay, so you don't really have to copy this down, but as long as you're kind of following along what's happening here, I'm just going to create a notebook. Let me make a text cell here. Pitfalls, possible pitfalls with functions. Okay, just gonna take some notes here. Possible pitfalls. One possible pitfall is something that involves scopes. So let me write it down here. Scopes. We haven't talked about it yet. This defines the lifetime of a variable. So here, let me make this into a markdown cell. Let's see. I'll call this scopes. Accessing misusing scopes. I'll call it misusing scopes. Okay, and we'll talk about what this means in a bit. One way we can misuse a scope is, let's say I were to define a function called foo. Right? It really doesn't matter what you call it. And let's say inside of this function, let's just keep it simple. Let's just say we have a variable called a, and then I'll set it equal to hello. Right, there you go. There's a variable, a string variable. Let's see if I can print it outside of the function. Right, so outside of it, I'm gonna go print a. Print a right here. Okay. When I play it, we're gonna get a error here. Right, this is name a is not defined. Right, there's a couple of reasons why this is not working. One is this is attempting to access. I'm not going to really formalize it. If anything, a right here, the lifetime of this variable is only within this function. Right. So scopes define the lifetime of a function, and in this case, this is a local variable. It's local only to this function. And then since this print function is outside of it, right, you see how it's not indented? Right, it's not indented, so this is technically outside. Okay, I hope that makes sense. I hope that makes sense. If I were to indent it, this print, it's technically inside of the foo function. And I have no more error. But it's not printing anything. Hopefully people might see why. It's because we didn't invoke the function, right? This function is defined, but in order to execute the instructions in the function, we have to invoke it. So this is invoking it. We call the name of the function, and then the parentheses. And there's nothing in the parentheses because there's no arguments. So let me press play here, and yeah, it says hello. Right? Okay, hopefully that makes sense. So just to reiterate, this is going to happen in the future too, not just with functions. Later on, we're going to jump into if statements, for loops. But yeah, this is going to be applicable later. Okay, let's see. Let's make things a little. Let's twist it a bit. This might look hard to read, and it's actually borderline spaghetti code here. But if I were to say a is equal to hi, right, what do you think is going to happen? Are we going to get an error here? Let me press play. See, we didn't get an error. It just printed hi. That's because this is actually called it's kind of a global variable. If you want to be more specific, this is actually a variable in the main scope. Now, this is a variable in the main scope, and then this local variable, this is a variable in the function scope. Now, once again, just to comment it out real quick, scopes define the lifetime of a variable. Right? The reason why scopes are useful is because it can make certain things anonymous and allow, it's kind of like for security things. Right? Like the outside can't really access this inside. Okay, hope that kind of makes sense here. A is accessing the main variable here, right? And if we were to call, foo, oh, I got rid of this print statement for some reason. Print a here. Right, I know this is going to look confusing. This is kind of borderline spaghetti code, but yeah, foo here should print hello, right? So it should print hi and then hello. Okay, hopefully people are cool with this. But the reason why I'm calling this spaghetti code is because it's actually borderlining something called global variables. So global variables is kind of a bad programming practice. It's arguably a bad programming practice. You'll see it towards the bottom of this notebook. Yeah, so towards the bottom of this notebook, it talks about function variables and scopes. But see, I'm not really going to go over this too much. It's actually probably going to make things a little more confusing than it is. Everything below this global variables, I'm not going to go over it, but you can feel free to play around with it if you're trying to see what's going on. But I really did the same exact thing in this notebook. It's the same thing, just kind of, I think it's easier to understand here. Okay, so this is variable in the main scope. Some people call it it could be a global scope. So global scope. If you're curious why global variables are arguably bad, then go ahead and try to read this lesson. Go ahead and try to go to the global variable section and attempt to see what's going on here, and then you'll see why global variables can lead to confusion. Okay, let's see. Yeah, this is a possible pitfall: misusing scopes, which is right here. Let's see this in the very beginning. In the very beginning, we got. Oh, so I was actually supposed to get an error here. I just got rid of all the edits. I was actually supposed to get an error, so I pressed play. It was supposed to say, "Oh, A doesn't exist." This is kind of a thing in Jupyter Notebooks. Right? Pretty much, in Jupyter Notebooks, there's something called a cell. Uh, Everything's a cell, but they're idempotent. I know we haven't talked about this word, but idempotence is a property where pretty much whenever you run the cell, it loads it into the kernel. I'm pretty much saying that A already exists because I defined it previously. Right? I defined it previously in the global scope and I pressed play. So this technically exists in the kernel. So I need to reset the kernel. I need to reset the kernel so I can get rid of all the previous history. Okay, so restart kernel. It's clear. Okay, cool. I reset the kernel, meaning I'm going to get an error here now, which is what we wanted. Okay, cool. Another possible pitfall. I talked about this a while ago, or 2 days ago. I mean, it's this pitfall. I would consider it hard coding a parameter, hard coding function parameters. So an example of hard coding function parameters is if we were to write some sort of function called a greet, right, and then maybe it takes in a argument name, and then all it's going to do is just kind of print it back out, like hello name. Right. Let's see what happens. Some people, when they're first starting, a lot of people would hard code this name right here. They'll say, "Oh, name is equal to Andrew right here," or whatever you want. Right? And then if you were to try to invoke the function, so greet, and then let me go ahead and give it some name here, like Bob, right? Some value. I mean, what's going to happen? It's going to say, "Hello, Andrew." Right? Hopefully, people see what's happening here, right? We wanted to say, "Hello, Bob." Bob does get sent into the function, but then it gets overwritten on the very first line. So yeah, hopefully people see what hard coding means. Okay, so you want to get rid of this because it's going to make it more general. Hello, Bob. Okay, so this is hard coding right here. Okay, let's see. Going off the previous bit, we did talk about scopes. This might look confusing, but what do you think this means? If I said name is equal to Bob, and then if I were to put name in here, all right, what do you think it's going to print still? Yeah, take a guess. Here, let me clear out this output. All right, take a guess what it's going to print. So I define a function, and then the first statement is, oh, set name equal to Bob. And then the next statement is saying, greet Bob. What do you think it's going to print? Make a guess. Okay, let's see. It says, hello, Andrew. Oh, hopefully that kind of makes sense. All right. It might not because there's kind of these same variable names. But these variables are actually different, by the way. They are different, even though they're the same. They're the same name. They're different because this is in the global. I mean, this is in the local scope, right? And so this is only being changed in the local, and then this is in the kind of like the global main scope. So yeah, this is just to show that these two are different. Some people might think this overwrites this line, but it doesn't. Okay, I don't mean to make things look super confusing. I'm just trying to make this a little easier right here, right? There's a section on the bottom of lesson 10 that talks about function variables and scope. And this is arguably kind of hard to interpret. Folks can try to read it, but I'm really trying to simplify this notebook right here. So hopefully that kind of makes sense. Let me think about this for a second. I don't want to make things too confusing. Let's see. Okay. Let me print name out just to prove it. So I'll print name. Name in main scope, right? Main or global is name. Right, so name in main scope is Bob. So yeah, basically I'm proving that the function right here, that this is working on the local variable scope. So when we get to this print statement, it's still using this. All right. That's enough of pitfalls. Let's see. I was gonna bring up a picture. Let me bring up a diagram. I'm gonna pull up my Google Drive real quick, just to kind of motivate why I might have made things look confusing. I was pretty much trying to promote a good programmer practice. Let me pull it up. Give me 1 second. Functions. Okay, we saw this a couple days ago. I brought up some slides, showed off some pictures here and there. All I really did was show pictures of black boxes. Let me pull it up. Yeah, we saw these pictures, some black boxes, and I was trying to lead up to this right here. Basically, functions, if used properly, it's going to look like this top diagram here. Right, the top diagram where we have clean code, it's modular. Functions are kind of working with each other. Right, this is kind of like one function is doing something, and then it's sending info to another function. Right, it is sending it through kind of one link only. So this is kind of an example of like clean coupling. Right, couple meaning they're working together. An example of kind of arguably spaghetti code would be like this, right? There's functions are too tightly coupled, meaning that if you were to make two functions work together and they have too many dependencies between each other, then this is going to lead to spaghetti code. As programs get more and more complex, you'll probably get a sense on how to go for clean code. But yeah, let's actually do an example later. In about 5 minutes, I'm gonna do something called a roulette example, and it should kind of give us a sense on the top diagram. Okay, let's see where we're at. So we talked about pitfalls with functions. Let me quit this. Okay, back to the lesson here. Just a couple more things and we'll be done. And then I'm going to jump into an application. Okay. A couple days ago, we ended off here. We talked about an example problem that you might see on the exam. Basically, we did a bunch of practice on this in the lesson, right? Remember, the lab. In the lab, we did a lot of easy ones. It was pretty much like, oh, write a function that prints something. Write a function that prints the sum. Right? Write a function that returns a sum. Write a function that returns a boolean. And yeah, in my opinion, these are easy ones. But on the exam, you'll see some variations of it. Like, this is an example problem. We saw this a couple days ago. Write a function that pretty much wraps the power of operator. And yeah, we ended off with this right here. That is what we ended off this. Let's see, it really, in the docstring, this really just is a wrapper for the power operator, which is 2 stars, right? That's really what it is. So, cool. Going further down, designing with functions. You don't really have to know what this means yet. We'll actually see the same exact function in a couple more weeks. Let me see. There's a lesson here called files. This is lesson 13. We're going to see the same exact thing later. If anything, you can probably just read this docstring and tell what it does. So let me look at it. So yeah, this docstring, it says, oh, it reads the first line in the file. It's not really that descriptive though. It might be more useful if the docstring was longer, like over here. Right? See, this is the same exact function. Read first line. It's got the same statements, right? The same 4 statements, but the docstring is more descriptive. So check this out. Let's go ahead and read the docstring and see what's happening. So here it is. All right, this is the docstring. You can actually use the help function to read the docstring. I know you can read it right here. Right? You can literally just read these comments. But sometimes functions are hidden in other files. Or sometimes they're hidden deep in computers, or maybe they're not released to the public at all. And sometimes it's necessary to use this Python function called help. And then if I say, oh, read first line, it's pretty much going to spit out the documentation. Right? This is the docstring that we saw above. Okay, cool. So read first line. It tells the purpose right here. Right? The purpose is, oh, it reads the first line in the file. And then what's the input to the function? It's the string, right? A name of the file to read. And then here it is. What is the output? It returns a string that contains the first line of some file. So let's go ahead and use it. Right, let me create another cell here. I'm going to create another cell and attempt to use it. Just I'm not even gonna read what's inside the black box. Right, we're going to pretend. Yeah, we're going to pretend like we can't see it, because typically functions are hidden somewhere else. So let's attempt to use it by only reading this description. Okay, so we do need a file. If you're curious, we actually do have a bunch of files here. So inside of the lessons folder, there's another folder here called files. And then there's more files here. I wouldn't recommend touching these yet. These are actually necessary for some lessons. But let me create another file here. Right, I'm just going to right click it, say new file. Let's see, I'll call it like blah. I'll just call it something, right? Blah.txt. And I'm just going to put in some random text in here, blah, blah, blah. Hello, hello, something, something. Right? I'm just putting some random text in this text file. Okay, let me go ahead and save it. See, this is a gray circle. This means it's unsaved changes. So I'm gonna go ahead and save it. Save. There it is. Text file is saved. And check this out. This text file is expecting a file. This function is expecting a file name as a parameter. So let me call it right here. So read first line, and then the parameter is some file name. It's actually the path of the file. So it is also relative to wherever this notebook is. This function's notebook is right here. And if we wanted to access the file we just created, we have to go into files. Right? So we got to represent the path. Files, then /, and then the name of the file, which is blah. Right? Blah.txt. So technically, this is the file name or file path. I guess the docstring could have been a little more specific. It should have said the name of the path or the location of the file. I think that's what this should have said instead. The location of the file to read. Okay, cool. So let's go ahead and test this. Or no, not let's test it yet. I'm just reading the docstring. Right, see, so that's the input, and it says it outputs the first line in the file. This means that this function, we can capture a result. So I'm going to capture the result into a string variable called line. That's where the output will go. And then finally, I can just go ahead and print it. Print line. Okay, let's go ahead and test it. So I'll press play. And you see what it's doing? It's printing blah, 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 right? Hopefully people see what it's doing, right? We kind of use the function to read the first line in this file. So that's what's happening. Right? We didn't really have to dive into the black box. Right? The black box is kind of looking at how it works. So yeah, that's kind of the importance of a docstring. It lets the reader know how to use things. Okay. Well, I'm going to skip over this because we're going to see it again on the lesson 13. Okay. Cool. Okay, and yeah, function variables and scopes. I already talked about this in another notebook. So you could look down here if you want. In my opinion, it might make things look a little more confusing. Okay, but yeah, we should be done with this notebook. Okay, let me do one more thing. So we're actually done with functions today. Let me pull it up. We are done with functions. So let's do something extra. Let's kind of apply some things and get a sneak peek into certain topics. So this is going to be some pretty cool stuff, actually. It's going to be some pretty cool stuff. Let me quit all of this. We're done with functions. Okay. I'm going to create a notebook, a random notebook. Let me actually create a folder here called examples. Okay, examples. Let me create a notebook in here. Okay, I'm going to build up to what classic Python might look like. I'm going to make this file called Roullete Simulator. Okay, Roullete Simulator. The reason why is because we're going to pretty much use functions and simulate rounds of this gambling game called roulette. For folks who might not have heard of this game, let me go ahead and look online. First of all, I don't condone gambling because there's a house edge. You're going to lose over time. But there's a roulette simulator here that might give you an idea on how this game works. Basically, how the game works is there's 37 numbers, 0 all the way to 36. And you pretty much bet on numbers. To keep things simple, I'm just going to bet on a single number, right? Meaning I'm just going to put like $10 on like 15 or something, right? So I put $10 on 15, and then let's go ahead and spin the wheel. So spin the wheel, and then it landed on 17. So I lost $10 right there. Let me do another round. All right, let me put $10 on 29. Then let me spin it. Spin the wheel. Then it lands on 0. So I lost another $10. Right, people kind of seeing what's happening here. Right, once again, I am keeping it simple. You can bet on like colors and odds and evens and dozens. There's a lot of different bets you can do. But to simplify the scenario, let me just bet on one thing only. Let's go on 17. 17. Oh, I landed on 0 again. That's pretty bad luck. Let me go on 29 again. Hopefully people are kind of getting a sense of what roulette is. Can you kind of imagine what the payout would be if you landed it? Right, like hypothetically, if I landed on 17 right here, right, how much will I get paid? Well, I mean, it depends on the casino, but typically it should pay 35 to 1, meaning that if I did land this number, I would get paid $350, 35 to 1. So hopefully people kind of see the house edge in play. Right, basically you deserve 37 to 1 because there are 37 numbers, but the house is only going to pay you 35 to 1. So that's where the house edge comes into play. Anyways, let's go ahead and simulate some rounds of roulette in Python. And this is going to be in the style of almost classic Python. So I'm going to write everything in one single cell. Okay, so let's see. The first thing we should probably think about is generating a random number. I mean, you could think about whatever first, like maybe taking input from a user. Yeah, you can do whatever order, but I'm going to focus on generating a random number first. So we already did this 2 days ago. You might remember we imported a function called random, right? And then we used this, I mean, not function, we imported a library which contains a function, right? It contains a function called, oh, right here, I'll pull it up, random Python. Right, there's a function in here, a class function called random integer. We used this a couple of days ago. I'm going to use this. You can kind of imagine that there's going to be a function. Do you remember a couple of days ago, we wrote a function called define roll dice? Right, remember this? We said roll dice of some number of sides. Right, this is from a couple of days ago. This means, oh, we're going to tell the function how many sides there are on the dice, and then the function will return us some random number. Right, so it was something like return a random.randint. Is it random int? Let me look at the random.randint. And then it took two parameters here, right? It was the lower bound and upper bound. So remember we had the lower bound is 1, the upper bound is number of sides. Right, people remember this from a couple days ago or the previous recording. Right, this is a random roll, right? It's a random roll from 1 to how many sides there are. In terms of the roulette wheel, let's see, oh, I quit the tab already. In terms of a roulette wheel, it might be more appropriate to rename the function, like spin wheel. All right, spin wheel, and then maybe the argument could have a better name, like what's a good name? Because it's technically not sides. Spin wheel. I'll call it like number of possibilities. Right, and technically, a roulette does start from 0. A roulette wheel starts from 0, and then all the way up to a number of possibilities. Oh, I think I spelled possibilities wrong. Let me just copy it over. There it is. Okay, and just to kind of comment this so people understand what it's doing, Right, let me put a doc string in here. So this is, I'm just going to keep it short. I know I've been doing pretty long doc strings lately, but I'm going to keep it short just because I think people already know what's going to happen. So this is just generates a random number, random roulette, random number of specified wheel. You could get more descriptive. I'll just leave it as this right now. Okay, let's go ahead and test this function. Right, meaning we're gonna invoke it. Right, let's make sure a random number generator works. So spin wheel. Right, and a number of possibilities. I'm just gonna hard code 36 in here. Right, the function allows us to control how big the wheel is. So let me spin the wheel. This function does return a number. Right, it does return a number, so we could technically capture this into some variable. Right, I'll call it roll result, because technically you're rolling the ball is rolling around a wheel. So I'm going to call it roll result, and let me print it out. Print ball landed on roll result, and this should be an F string. Okay, I just pressed play. Ball landed on 13. All right, let me test it again. Test it again. Let me press play again. Ball landed on 8. Let me run it again. 12, 33. Okay. Cool. I'm just running it over and over again. Okay, cool. It looks like our spin wheel function is working, and it's general enough to where we can rig the game easily. Right? We can rig the game just by kind of changing this single number. Okay, let's work. Let's see what we should do next. Maybe we should prompt the user for how much they're betting, right? Like in the roulette game that I pulled up. Let me see. Oh, I already exited it, but there were kind of like two inputs, right? Like there was how many chips you're picking up, and then the next input is where you're putting the chips. So you can kind of imagine. Here, I'm gonna remove this real quick. You can kind of imagine that there's gonna be some sort of input that comes from a user, right? And we're gonna ask the user like, how much are you betting? Right. This is a function that here you'll see what it does. Right, how much are you betting? So I'll press enter, control enter. Right. This function pretty much asks the user to type something. So I can type in something like 10, and then it'll complete the program. All right. If anything, this is a Python function. It's a native Python function. By default it returns a string. So it might be useful to convert that string into an integer. All right, so I'm going to convert it to an integer. This way we can kind of do some math with it. It's really hard to do math with strings, but if you convert it to an integer, a number, you can do math with it. So I'll convert it to an integer, and then let me go ahead and capture it into a variable called a wager. Right, this is a variable that represents how many chips we pick up. So let me go ahead and test it. So let's test it. Play. How much are you betting? Let's just say like 10 bucks. Right, enter. And there we go. I'm just testing the input. So wager becomes the integer 10. It's whatever you type in. Okay, so how much are you betting? 10 bucks. Let me actually put like a dollar sign here. Put a dollar sign here just so the prompt looks a little neater. So how much are you betting? Dollar sign and 10 bucks. Okay, there we go. Cool. There was another input we should grab. Like what are you putting the money on? So in this case, you could call it like a guess, right? Because technically, when you're betting in roulette, you're guessing where it's going to go. Right, so I'll say guess is equal to the integer value of some input. And in this case, the input, I'm just going to prompt the user like, what number are you betting on? How much are you betting? What number are you betting on? So let's go ahead and test it real quick. Control. How much are you betting? Let's go like 10 bucks. And then what number are you betting on, right? Let's say I were to bet on lucky number 15. Right, and then press enter. Right, it doesn't do anything yet. I'm just testing frequently. Right? I want to test frequently so I can catch errors earlier on. Okay. Let's go ahead and simulate a round of roulette. So you can kind of imagine that this is technically like the beginning of a round. It might be useful to make this into a function. So imagine we had a function that's called, let's see, I'll call it play round. I'll call it play round for now. The goal of this function is just to simulate one round of roulette. So let me go ahead and make this a doc string. Simulate one round of roulette. Okay, and I will add some arguments into here real quick, and it's going to make sense after I make this doc string. So let me actually make this a multi-line doc string, because this is going to be a relatively interesting function. Simulates one round of roulette. Okay, typically when you play some sort of gambling game, there is an input, right? Like pretty much you need money. Right? You need money in order to play. So it might be necessary to add an argument that represents your buy-in, right? Or your bankroll. So I'll call it bankroll. So this means that in the parentheses, I'll put a thing called a bankroll. Right, so this simulates one round of roulette. The argument is bankroll, a number that represents our money, that represents the player's money. All right, so does that kind of make sense? When we play around, we need money. So this has to be an input. Okay, so check this out. I'm going to go ahead and indent these two lines. All right, these two lines, I want to make it belong in the function. So there you go. I just indented it. All right, the reason why I made it belong in the function is because I'm planning on just calling it. I'm planning on just invoking it somewhere down here. Right, so imagine if these were in some other file, and then I'm at the bottom here. I just say play around. Right, let's say play around, and then let's say I bought in for like 200. Right, so this is saying, hey, play around, but tell the function I'm playing with $200. So $200 goes to here, right? Let me do a print statement. Let me do a print statement. I'm just going to print out, you have this much money. You have this much money. It's the whatever the bankroll is. You have this money. Okay, let me test this real quick. So let's play. Okay, cool. So technically, the first instruction that runs is this play. Right? It says play round, and it goes up here, runs this, and then prints. Oh, you have $200. Right, and then how much are you betting? So let's say I bet 10 bucks, and then let me say I'm betting on number 15. Right, people kind of seeing what I'm doing. I'm just kind of testing things frequently. Okay. Okay, let's do some cool stuff now. Um, if anything, I'm gonna generalize these variables. So 200 technically can be renamed to something called a buy-in, because when you enter a casino, you typically buy in. It's pretty much a synonym for bankroll. So I'm gonna give it a name, buy-in. Go to 200 bucks. Let me think about this real quick. I need to get 200 bucks. Cool. You know what? I'm actually gonna call this balance instead. This will make sense in a bit. So I'm gonna rename this to balance. All right, so we initialize a balance variable 200, and we throw balance into bankroll. Does that kind of make sense? So yeah, it's the same thing right here. Let me press play. 10, 15. Okay, just testing this. What should we do next? Right, the play round. Right, we got two inputs. This is like saying we picked up the chips, right, and we put the chips on some number. Right, what happens next? We start spinning the wheel. Right, that's what happens when you finish betting. So we do have a function called spin wheel, and we can go ahead and call it. All right, we can go ahead and spin the wheel. So spin wheel, and it does take an argument. The argument represents how many slices there are on it, right? Number of possibilities. So in the example we saw earlier, there was 36 numbers, um, 0 to 36. And this function actually returns a number. So we could go ahead and capture it in some variable called roll result. Right, people see what's happening here. So we spin the wheel, the ball lands on something, and then it prints here, roll result. So if anything, it might be useful to kind of echo out the roll result. Right? You can kind of imagine the dealer. Right? The dealer spins the wheel, and then they say, "Oh, ball landed on some number. Ball landed on roll result." So ball landed on roll result. Let's see. Okay, let me actually press play real quick just to make sure we're good. Okay, so I'll press play. Okay, so we are here, right? Once again, this is the first instruction that happens. Right? These don't really happen yet. They don't really happen. So this just happens, and then we say, hey, execute the instructions in play round. So now we're here. Hopefully people are getting good at tracing this. So how much are you betting? Let's go $10, and then let's say I bet on number 15. It doesn't matter, as long as it's between 0 and 36. Okay, press enter, and it says ball landed on 5. Right, so what should have happened? Right, see what I mean? We should have lost 10 bucks. Right, does that make sense? So what do we have to do next? This is actually going past what we learned already, but we need to implement some decisions here, right? Like basically, we need to look at roll result and kind of decide whether or not we win money. It's kind of like some if statements, but we'll talk about if statements in a while. But this is kind of a sneak peek. And you can kind of imagine that if something, we win, right? Else we lose. So what's the condition for winning? Right? The condition for winning is if our guess is the same as roll result. Right? Does that make sense? Right, so we could make a condition if guess is equal to roll result. Right? 2 equals. Right? It requires 2 because this is actually comparing for equality. Okay, so if they're both equal, then we win money. Right, so this is the part where your design might kind of vary. In this case, I'm going to go for a design where the function is going to return a number. So imagine, so in this doctrine, right? Let's say that this function returns the resulting bankroll. Right? Does that kind of make sense what it's supposed to return? Right? This means that if we got it right, then we should return a bigger bankroll. Does that make sense? We started with this amount of money, and if we got it right, we should return with a bigger bankroll. So the bigger bankroll here is bankroll plus wager times 35. People see what I mean? This is saying return your current bankroll, but add on how much you won. Right? The wager times 35 is the casino payout. So yeah, this is returning the bigger bankroll. And then we do need an else as well, right? This is actually else. We'll cover if and else later. But this is saying if we didn't get it right, then we lost. So we should return a smaller bankroll, right? So return bankroll minus wager. Does that make sense? Like if we bet $10 and we didn't land on it, then we lose $10. So we return our balance bankroll minus the wager. Okay, so if anything, since this function does return something, right? This is a play round. It does return a number. The caller should probably capture that value. Right? The caller is right here. Right? The caller is in the main scope. So the play round does return a number, meaning that we should capture it. Right? So this might look weird, but I'm going to say balance is equal to play round balance. Now people kind of see what's happening here. Right? We initialize balance 200, and then going down here, let me clear this right here. The right side gets evaluated first. So we're going to play a round, and inside of that round, either of these is going to happen. Right? We're either going to return a bigger one or return a smaller one. Right? So this is going to evaluate to some number. So does that make sense? Right? It's going to evaluate to one of these numbers. So then our balance will get updated. It will get overwritten. Right, so here, let's go ahead and see what's going on. Let me just read this real quick, because there might be some things we need to add to make things look neater. Give me 1 second. Around. Okay, let me copy this. Let me just invoke the function twice. So all I did was copy and paste the function because I'm planning on playing 2 rounds. Right, does that make sense? So here, I'll press play. Okay, so cool. So we have $200. This is our first round. Right, so I'll put $10. Press enter. What number are you betting on? Let's go 15. Okay, press enter. Okay, press enter, and it says ball landed on 10. So we lost, right? We lost because we didn't guess right. And yeah, does that make sense? We now have $190. Right? It says we have $190 because we're in the second round now. Right? We went into the second round. We have a new balance, by the way, right? Because balance got updated previously. Right? We got balance because this one got returned. So we play another round, and then it's gonna oh, here's your current bankroll. And then it's gonna do the same thing, right? How much are you betting? Right, let's do the same thing. $10. Let me go put it on 0. And then ball landed on 23, so I lost $10 there. But if anything, it might be useful to kind of loop this. So if you want to play multiple rounds, you could just play multiple rounds like this. Right? People kind of see what's going on here. This is saying play multiple rounds and update the balance every time. Right? That's what the equal sign is doing. It's updating a new balance. You could do this, or you could loop it. This is kind of far ahead, though. I'll show folks how far ahead it is. So loops are towards the later end of class. It's I mean the semester. It's over here, for loop and while loop. So it's kind of further ahead, but let's give folks a cool sneak peek, right? This might be kind of readable, so let me clear out that. I can actually loop this play around here. Right? It might be readable. I could say, well, here, actually, let's think about it. Let's think about it. When do people stop gambling? Maybe when they run out of money, right? So what's a condition that represents that you do have money? Right? So like basically, I'm trying to say repeat this while we have money. Right? So you could represent a condition that says while we have money. Kind of see what this says. Once again, we'll cover this later, but this is a while loop. It's saying while this condition is true, keep running the body. Right? The body is just one statement. So let me go ahead and run it. How much are you betting? Let's go 10 bucks. Enter. What number are you betting on? Let's go 0. Enter. Okay, ball landed on 33, so we lost. And I have 190. And here we are. We are looped in the second iteration. Our iteration means we're on the second round. So how much are you betting? Let's do the same thing. 10, 0 again. And then ball landed on 4 this time. I have 180 bucks. Yep, there it is. I lost it. Yeah, so this is actually going to keep playing. It's actually going to force me to play over and over again until I run out of money. If you did want to stop playing, you could press this stop button. Or you could just go all in. Right, so I'm going to go all in, put 180 on 0. And I should lose all my money there. There it is. See, I lost all my money, meaning that this condition became false. Right, 0 is not greater than 0. And then we end up terminating. Pretty cool stuff, right? We kind of just, here's our code. Right, this is kind of like what classic Python is. It's kind of like you have these functions, right, and then you have like a main. You can think of this as a main. And all the main does is call the functions that you already built. Right, in this case, all the main did was call the play around function. Right, and then this play around function calls the spin wheel. Right, so I'm trying to represent this picture right here. Right, there's some coupling between the functions, but the coupling is kind of like only one link. Right, it's not like a bunch of links. This is kind of like spaghetti. Okay, hope that kind of makes sense what we did. As programs get fancier and fancier, you'll see more and more functions work together. Okay, you know what? Here, let me make this look a little neater. This is actually kind of hard to read. Let me clean it up a bit. It's up to folks to clean it up however you want. For me, I'm probably just going to print out a bunch of equal signs. Print F, oops, print, let me just print out a bunch of equal signs. I'll go equals times 20 times 40, I mean. This means I'm going to print out 40 equal signs. And you know what? I might as well just use some HTML. It's probably going to look nicer if I do that. Like right here. Like in this branch, this is technically the winning branch. So it might be, you could say print you win. You win, right? You could do that. I'm gonna use some HTML. This way it'll look a little neater. So let's see. Let's use HTML instead. There is a library I should probably import. I forgot off the top of my head. I think it's from ipython.display. Import HTML. I think. Let me double check. ipython.display. Yeah, it looks right. Okay, cool. This is not really classic Python. IPython stands for Interactive Python. It adds in some features to Jupyter Notebook. Okay, so let's go ahead and put this in. Let's see. in the winning branch, right, I'm just going to go ahead and say you win. Print, or not, I got to make a string. Right, I got to make an HTML string that says you win. Let's see. Let me think about how I'm going to do this. I'll probably make it a multi-line string, or not multi-line. I'm just going to use triple quotes, just in case. And then inside of it, I'm going to do a header. An H1 header, meaning it's going to be a large title. And I'm just going to say, you win. Right, so this is an HTML string. I'll probably make it green. So one way you can make a header green is by saying style equals color. Style equals some string. My bad. So some quotes here, and color, colon, and whatever color you want. So I'm just going to say green. Right, so there we go. This is a HTML string. If anything, you got to convert it to an HTML object. Right, so let me wrap this thing in HTML and then display it. So let me display it, renders. Cool, there it is. Let me copy and paste this for the losing case. So copy, paste, and then for here, I'm going to say you lose. And make it red instead. Okay, let's go ahead and test this. I just inserted a bit of HTML and some equal signs here. It should be a little neater. Okay, cool. So this is really what the main code looks like. You can kind of imagine that everything else is black boxed away. So press play, and there we go. How much are we betting? Let's go 10 bucks. Let's go 21, and then enter. And then, oh, I lost because ball landed on 16. Okay, let's try again. How much are you betting? Let's go like, let's go $10 again. Let's go 15. Enter. I lost again. So now I have $180. All right, people are kind of seeing what's going on here. Let's go 10 bucks again. And let's go bet on number 4. Or no, actually 4 is actually an unlucky number. In Chinese, 4 sounds like death. It sounds like you're saying death. So I'm not going to use 4. Let's go 13. 13. Oh, I lost. Okay, let me just go all in. So I have 170 bucks. Let me just go all in. This way I can lose and then terminate the while loop. 170. What? How much are you betting on? Let's go 0. Then I lost. And my money went back down to 0. So our while loop terminates, right? Because this condition becomes false. Okay, hopefully people found this pretty cool. We kind of applied functions. Yeah, this is kind of just a fun example, right? Actually, it's not fun because we lost. But, you know. Now, let me show folks another example. This might look super long. I actually use Python to grade my C++ students. If folks want to get a sneak peek into it, let me see. Oh, I'm on the wrong computer. So I need to update something. I use Python functions to grade my CS-11 students. It's the C++ class. So let me show folks what that code looks like. Let me update this. Do a git pull. You don't have to know how to do this. It's let's see. So one of the later assignments it did was something called a card validator, and pretty much this was an assignment where you type in a card number, and then their assignment would verify whether or not it's a valid card. It's using something called the Loon algorithm. This is kind of outside of the scope of the class, but there's an algorithm. It's called Loon algorithm, and it's pretty much a way of validating typos in identification numbers. So yeah, I'm kind of going off a tangent. My point is, I use Python right, to grade my CS-11 students. So there's a file here called grade.py. This is a Python file. And yeah, you can see some Python here. Right, this is a classic Python source code file. Right? It's not a Jupyter notebook. I imported a bunch of things here. I have a comment here. I have a comment here. It's pretty much telling me to fix something later. Because I'll talk about this later. Yeah, so I imported some libraries that I need to use. I set up some global variables, or they're not really variables. They're just things to represent something. Let's see. And then you see all these functions here. Right? There's a bunch of functions, right? This define, right? I wrote a function to check if they named their assignment correctly. I have another function here that checks if it even compiles. Right? In some languages, there's a step where you have to compile code. Python, you don't really have to compile it. You just kind of run it. But other languages, there's something called compilation. So I wrote a function to do that. And then finally, test cases. This is kind of hacky right here, but this is where most of my work is being done. All right, I'm pretty much saying, hey, test their program with a list of test cases. Right, this is a list, by the way. This is a list of lists. As people see the data structure here, there's a single list that has multiple lists inside of it. So, and then I'm pretty much iterating through all of it. And then if they got it wrong, subtract points. Right? This is saying, oh, if they got it wrong, then subtract points from the score. Now, once again, this is in a function. Right? This function is called check test cases. Right here, right? Check test cases. And where I call it, right? Let's see where I call it. I'm just going to jump to it. I call it right here. Right? I have a function called grade, which uses the check test cases function. Right? So yeah, can people kind of see what I mean? What I mean by modularity? But basically, I have functions everywhere, and I'm just kind of reusing it for other assignments here and there. Because as you write more and more code, it's likely that things get repeated. Okay, so that code I showed, I know it's kind of a lot to look at. My code is not the cleanest. I kind of wrote that really fast. In my opinion, it borders between these two right here. I do have a bunch of to-dos in there. Basically, the to-dos is saying, hey, make it cleaner. That's pretty much what the to-dos is saying. Okay, hopefully people have a sense on what functions are. They allow us to reuse computation. Modularity is improved a lot too. You can read things easier. And yeah, that's pretty much it. Right? Functions are really nice stuff. Okay, cool. So that's it for today. Let's see what else we have. So just for some concluding thoughts. Next week, we're going to be talking about interactive programs. We'll have one more assignment before a little break. This is a break so people can kind of catch up for the midterm. Cool. All right. Thank you all for coming, and have a great day. Great night.